Hello everyone, welcome back to our TSW YouTube channel. Hope you liked our previous content of this series known as Data Hacks. We are back with our next hack, but before starting, don't forget to subscribe to our channel and press that bell icon so that you get a notification every time there's a new video. Let's begin. Today we are going to discuss an important topic used for EDA purposes while training your machine learning algorithm, and that is visualization. Visualization is the process of plotting graphs to analyze the dataset effectively and find hidden trends. Now let's look at the code. We will use Matplotlib and Seaborn for our purpose today. We then need to read the data into our data frame, and the dataset used here contains the information of cancer patients and their symptoms. Now we will begin with the visualization. Let's start with some basic plots. First of all, we will create a basic bar plot using Pandas functionality of plotting. Here we are plotting the value counts of the column age at diagnosis along the x-axis. So basically this plot is showing the occurrence of each age from this, and from this visualization we can observe that 73 is the most common age. Similarly, we can plot a line chart using Matplotlib to show the same data in a different format. In the previous chart, we observed that the values in the x-axis were in descending order, but in this one, the x-axis is in ascending order and the y-axis is dependent on x-axis, so it provides another way to visualize the same data. After the line chart, we will plot a pie chart to illustrate the percentage share of gender column to see which gender is more prone to get affected. And we can observe here that almost 88% of the patients are male. Now we can come to some advanced and interactive plots. For this purpose, we will use the Seaborn library. Seaborn provides more features and more visualization techniques as compared to previous libraries and is easier to implement. One of the very common plots using Seaborn is a cluster map. We can use this map to see the correlation between the columns of a data frame. Here we are using only the first 7 to 8 rows of our data frame to visualize so that it does not become cumbersome. The color coding in this plot is such that the lighter the color, the more interdependent the features are. That is, we can see that the diagonal is the lighter color because it shows the relationship between the same attribute, so it will always be 1. Now for detecting outliers in any particular column, Seaborn has many options such as first, box plot. We are using here box plot to evaluate the outliers of a column and its spread. The 3 dots in the left represent the outliers in the column, and the other part, that is this part, is the spread of the column. That means the area filled with blue color is where the column is max dense. That is, the column of age diagnosis has the highest people in the age group of 60 to 75. We can use, second is Violin Plot. We can use Violin Plot to observe the density between 2 columns. So here we can see the plot for relation between gender and age at diagnosis. This plot shows the density for each category of the gender. So this is the area where the Y max is dense maximum for the male gender and this for the female gender. Third is Swarm Plot. Swarm plot shows a relationship between 3 columns and is a good complement to the above 2 plots. Like here, using swarm plot, we can see that for asides degree 2, there is only one non-alcoholic at the age of around 50. We can similarly distinguish non-alcoholics in other categories of degree as outliers. Last one today is joint plot. Joint plots can be used to display the relationship between 2 columns with multiple types of plots in a single graph. Here we are going to use joint plot to show kernel density distribution between age at diagnosis and packs of cigarettes used, and also the line plot to show the distribution separately. It also provides us a method to analyze these columns individually as well as the relationship between them. So these were some basic plots which could make your analysis easy and help you speed up your EDA processes. That's it for today. See you next time. Don't forget to give a thumbs up if you liked the video and share it amongst your friends and colleagues to spread the knowledge. Link to the code shown in the video is provided in the description below. Thank you all.